In this video, we are going to see everything in and around a stack data structure. A stack is a linear data structure in which the insertion of a new element and the removal of an existing element takes place at the same end, which is represented as the top of the stack. And to implement the stack, it is required to maintain the pointer to the top of the stack, as we can access the elements only from the top of the stack. Now we can see the basic operations on the stack. First operation is the push, which adds an item to the stack, and if the stack is full, then it is said to be an overflow condition. And next operation is the pop, which removes an item from the stack, and these items are popped in the reverse order in which they are pushed. And if the stack is empty, then it is said to be an underflow condition. So everything is done in the top place of the stack, top position. Every operation is done in the top. So, and top returns the top element of the stack and is empty. This returns true if the stack is empty, else false. And size returns the size of the stack. So these are the basic operations on the stack. And for to understand the stack, you can see a practical example of stack. And consider a simple scenario like a plate stacked over another in a canteen. The plate which is at the top is the first one to be removed. So this stack can first for that follows simply last in first out order or first in last out order. So this stack follows this LIFO or philo order. And now we can move to the types of stacks. For fixed size stack, and we are having a dynamic size stack, and now we can see the fixed size stack. This has a fixed size, that is, it does not grow or shrink dynamically. If the stack is full and if an attempt is made to add an element, then an overflow error occurs. And if the stack is empty and if an attempt is made to remove an element, then it is an underflow condition. And then we move to the dynamic size stack. This can grow or shrink dynamically, and when the stack is full, it automatically increases its size to accommodate the new element. And when the stack is empty, it decreases its size. So this is all about the types of stacks. And now we can move to the applications of the stack. And this applications include infix to postfix or prefix conversions, and forward and backward features in web browsers. So these stacks are used in these things and used in many algorithms like Tower of Hanoi, tree traversals, stock span problems, and histogram problems. And in some backtracking problems like iron queens, and in the games like checkers, we dive into some way. If it is not efficient, we come back to the previous state and go in some other path to get back to the back from a current state. We need to store the previous state. For that purpose, we need a stack. And next application is in memory management in computers. These stacks are used, and each program that is running in a computer system has its own memory allocations. And this uses stacks. And in string reversal is another application of stack. Here one by one each character gets into the stack. So first character in the string is at the bottom of the stack and last item will be at the top of the stack. So during the pop operation, which is done from the top, then we get the string in the reverse order. And the stack also helps in implementing function calls in computers. That is, the last called function is always completed first. And the stacks are used to implement the undo redo operation in the text editor. these are some of the examples of applications of stack. And now we go to the move to the implementation of stack. That is, these stacks or linear data structure that operates on the principle last in first out, and these are commonly used in computer science and in variety of applications that we already said, including the evaluation of expressions, function calls, and memory management. And these are implemented in two ways, that is using arrays and using linked list. We are not going to the going programmatically now, but these are the two ways that stack can be implemented, using an array and using linked list. This linked list we are going to see in the next video. Subscribe to my channel if you feel contented. Like and share my videos with your friends.